Morning and welcome back to my channel. My name is Himanshu Gupta and in today's session I'll be covering circular linked list. So far we have already covered linear linked list or singly linked list, singly linked list and doubly linked list. Basically linked list is collection of nodes where each node contains the address of the another node. In singly linked list the data structure contains two variables, one for storing the data and another for storing the address of the next node. Whereas in the doubly linked list, we have three data fields, one for storing data, another for storing the address of previous member, and one for storing the address of the next node, right? So a circular linked list is basically like a normal linked list. The only difference is that the last element of the list points to the first element of the list. I mean, if we join the last element with the first element, the list becomes circular. So in today's session, we are going to implement various functions of the circular linked list. We'll be performing insertion, insertion at beginning of the circular linked list, insertion at last position of the circular linked list, and insertion after some value. Likewise, we'll be implementing deletion, and again we have three categories of deletion. I mean, we'll implement a function to delete the first node of the circular linked list, to delete the last node of the list, and delete a particular node, I mean some value, right? Next we'll be implementing a function to search in the linked list. This function will simply return 1 or 0. I mean, 1 means we found the element in the list and 0 means we could not found the element in the list. A function display which which will display all the elements of the linked list, and another function count nodes which will count the number of nodes in the linked list. So let's begin with the first function, insertion. Insertion at the beginning. Before implementing the function, we need to define the structure of the list. So structure will be exactly same as we have used in the case of singly linked list. Struct node, you can use type def, struct node, an integer data variable to store the data, and struct node next. This field will store the address of the next node, and this is our structure. Now we need to declare a global variable, global pointer head, which will always point to the first element of the list. So we can declare it like this: node head. Initially, let's initialize it with null. Okay, now let's discuss the our first method, insert at beginning, void insert at beginning. This is the value that we'll be inserting in the list. Okay, first let me draw a list. Suppose this is our circular linked list, like this. This is the first node head. This is the first node, and the list contains 5 nodes. Now we want to insert an element, a new node before the first node. That means somewhere at this position. This I am calling this node as new node n. Right now you can see clearly. You can clearly see that whether we insert a new node at the beginning of the list or insert the new node at the last of the list, the insertion will be at this place only, right? I mean before the head. So what is the difference? Why we are implementing the two different functions for inserting a new node at the beginning and insertion at the last, when they are doing the almost same thing. The only difference in both the cases is that if we are inserting a new node at the beginning, the head pointer is being changed. I mean, in that case, we'll call this new node as the first node, and our head pointer will be pointing towards this location. Right? Our head will be pointing to the new node. While if we are inserting this as a last node, then our head will keep pointing to the original first node, right? So this is the only difference. Now let's first uh, you know discuss the insertion at beginning. So first of all, we will check if if our head pointer is null. That means our list is initially empty, right? So first of all, we need to create a new node, then only we'll be able to insert a new node. So we'll create a new node like this. Sorry, node. I'm calling the new node as n is equal to node malloc and size of node. Size of node. So this malloc function will create will reserve a memory space equivalent to the size of this node, and will return a void type of pointer, which we need to explicitly typecast using this using this kind of typecasting, and the pointer will be stored in our new node. Right now we need to check if head is equal to null. What does it implies? It means that our list is initially empty. Our list is empty. So our new node will become the first node, and that will be our head node, right? So if this is the case, then our head node will be storing the address of this first node, and if there is only one node in the circular linked list, suppose this is the new node, then its next will store the address of itself, then only it will become circular, right? So head next is equal to, or not head next, this new node, next of this new node, sorry, the next of this new node will point to head, right? Okay, now we have already discussed in our previous implementations of linear linked list and doubly linked list that if we want to insert a new node at position k, we need to go to position k minus 1 so that we can set the correct pointers. So if we want to insert a new node before head, this if we are inserting a new node before head, that means this new node is after the last node. This new node is after the last node. So somehow we need to traverse this linked list, this circular linked list, and need to come at this position. I mean at the last position. So we'll use a loop to traverse the list like this. Hold this. Hold this. We'll create a temporary node temp. We'll initialize this temporary node with the head, and while the next of this temporary node is not equal to head, this loop will keep on running and will keep on switching to the next node using this temp is equal to next of temp, right? So basically suppose this is our list. Suppose this is our list, this is our head. Okay, when will we come out from this loop? When the next of temp is not when the next of temp becomes equal to head. I mean when this condition becomes false. And when will this condition becomes false? When next of temp will be pointing towards the head. I mean when we will reach to this node, that means the last node. So in this case our temporary pointer will be pointing towards the last node. And now we have to store a new node just after the temporary node, right? So this is our new node, right? So what should we write? We simply, it is very intuitive, the next of temp should point to the new node. The next of temp is equal to new node, and new node next of new node should points to the head is equal to head. And now we need to check the change the position of head. Now our new node is the head node. So head is equal to the new node. This is the insertion at the beginning. This is our else, and this is our function insert at beginning. So I hope you have understood this. Now let's implement insertion at the last. So using the same diagram, we'll be doing exactly same thing, right? First we need to traverse this linked list. We have to somehow come to the last node, and after the last node we have to insert this new node, right? So the only change is that the next of temp, in that case the next of temp will be n, and next of new will be equal to head. The only difference is that we need not to change the position of head pointer in this case, right? Otherwise the whole implementation will be almost same. So let's quickly write this code also. B void insert at and this is the value. I think I forget one line in the last code. Let me check. Okay, so here I'm sorry, in the last code we have not initialized the data value of this, the data of n is equal to n. So please make this correction. And okay, so first of all, if we are going to insert a new node in the linked list, we first need a node, then only we'll be able to insert. So first create a new node like this, node n is equal to node malloc and size of node, right? Initialize it, data of n is equal to n. Okay, now check the case if the linked list is empty. If head is equal to null, this means our linked list is empty, and in that case our new node will become the head. Head is equal to new node, and the next of new node will be head because it is a circular linked list. Else what we have to do in the else section, simply create a temporary node to traverse the circular linked list like we have done in the last function. Node temp, initialize it with the head. Actually we have to traverse to the last node of the list, because after the last node we have to insert a new node. So while the next of temp is not equal to head, right? Temp is equal to next of temp. So when will come out of this loop, the next of temp will be equal to head, right? So we have come to the last position of the list. Suppose this is head and this is the last node. Now we have to insert a new node after the temporary node, after the last node, right? So simply this is to be done. I mean, simply we have to write two lines. The next of temp is equal to new node, and next of new node is equal to head, and that's it. This is our insert at end function. Okay, now let's see the third implementation of insert function. I mean third variation. See what we have to do. User will enter a value v, and we actually need to search this value in the linked list, and after this value we have to insert a new node, right? So let me call this function as void insert after. So in the insert after function, we need to pass two values, right? I mean one value which we have to search, and the one that will be inserted after this value v. So I need to pass two variables here, int v and int n. So first of all, I need to create a new node. It is very intuitive. We first need a node, then only we'll be able to create the node, then only we'll be able to insert the node. So let's create a new node. Node n is equal to node malloc size of node. Let's initialize it. Data of new node is equal to n. Okay, now our usual case, if head is equal to null, this means that the linked list is empty and the node that we are going to insert is the first node. So if the node we are going to insert is the first node, that means we cannot insert a new node after this value v. So that means user has entered the incorrect value, incorrect input, right? So in this case, we may print a message that list is empty, so cannot insert after %t. Since the list is empty, it does not have any node which contains the value v, so we cannot insert after v, right? So in this case, we may simply delete the memory allocated into the our new node like this, and we may return from here. Otherwise, we first need to search this value in the list. So I'll be using a do while loop for searching. Sorry, before this, let's create a temporary node. Struct node, a temporary node temp, initialize it with the head, right? Now I need a loop while temp is not equal to head. Okay, let me first discuss the logic. Suppose basically what we are trying to do in here, suppose this is our circular linked list. This is our suppose circular linked list like this. This is the circular linked list. This is our first node. I am calling it as head. It may contain various other nodes. So suppose I want to insert a new node after a value 20, right? This is suppose our 30, 40. Suppose this 40 here. Suppose this is our circular linked list. So first I need to search for this value, after which we'll be inserting a new node. Then how will we insert? Suppose this is our new node that we have just created. We'll initialize it with n. Okay, now I want to insert this new node after this node. So first we'll find this node. So our temporary pointer will be pointing towards should point towards this this node. Now what will we do? What will be our logic? The next of this new node should point to the next of temp. I mean, we should write next of new node is equal to next of temp. So we have joined one pointer like this, and next of temp should point to n. Next of temp next is equal to n. So this is what we have to do, right? So while temp is not equal to null, we'll check if temp data is equal to v. I mean, if we have reached to the node which is our desired node that contains the value that we are searching for v, then what we have to do, we have to write these two lines, right? I mean, the next of new is equal to next of temp, and next of temp is equal to n, and that's it. We have successfully inserted our node, and if our task is over, we can return from here. And this is the while loop. See, if we could not find this value v that user has supplied, I mean, if we found the value v, then we will be successfully insert the new node between after the desired value v. Otherwise, when we come out from this loop, that means we could not found the value v. So we can print that message here, printf node with value %t not found, right, v. And if we could not found the value v, that means we cannot insert a new node, we cannot insert the new node after the v. So the node that we have just created, we have just created a new node, we need to free the new node using the free function, free n. So that's it. So this is the implementation of our function new node insert after. So what we have done, we have first created a new node, initialized the new node, then we checked if the list is empty. If the list is empty, then it means that the node that we are inserting is the only node, is the first node. So we cannot insert after the value v, right? So it is the invalid choice. So we simply deleted the new node that we have just created. After that, what we have done, we searched for the node v in the linked list, and when we found the node, we have simply inserted the new node by setting the two pointers. The next of n should point to the next of temp, and next of temp should point to the new node. So it is a simple logic. Now let's talk about the deletion. Let's discuss the deletion. Deletion. Deletion in circular linked list. In deletion also, we'll be implementing three functions. Delete first, delete last, and delete node. Basically in this function we'll pass a value. We have to search this value and delete the node, right? So before actually implementing the function, let's discuss the logic first. So suppose we want to delete the first node, and this is our circular linked list like this. Suppose this is our circular linked list. Okay, this is our head node, that means first node, and this is the last node. Suppose we want to delete the first node, we have to delete this head node, right? So what we need to do, we will connect the last node with the next node of the head node, then only we can free this node, right, in order to make it circular. So we first need to traverse this node and need to come one node before the head node, I mean at the last node. So we'll take a temporary node and traverse the list as usual. So somehow we have to come to the last node like this. So our temp will be pointing towards this, and then we'll simply what we need to write, the next of temp is equal to next of head, right? Then what we can do, head is equal to next of head. We have changed the head pointer. Now our head pointer becomes this node, the next node of the head pointer, and this is our, sorry, before, just a second, because there is some problem. If we do like this, the implementation is okay, but in this case we will not be able to delete the node. I mean, we have correctly set the pointers, but we don't have any pointer which is currently storing the address of this head node. So we need to do something else. We need to create a new pointer which stores the address of the current head. So let's declare a new variable, supposed to delete, and initialize it with the head. Okay, so we have declared a variable, we have declared a pointer to delete, which currently holds the address of the first node. Now we can write like this. Now we can set next of temp is equal to next of head, and head is equal to next of head. Now it's okay. Now we can safely free to delete, right? So this is what we will do in the delete first method. Now suppose we want to delete the last node. If we have to delete the last node, this is delete first. So basically in data structures linked list, whenever you feel some problem, just draw the structure, draw the linked list, and then you will understand what to do. Now suppose I have to implement a function delete last. I mean, we have to delete the last node. So let me again draw a linked list, circular linked list like this. So this is our head node and this is our last node that we want to delete. This node is to be deleted, right? So somehow you have already seen in this in the implementation of delete first. Somehow I need a pointer before I need to store the address of the previous node of this node that we are going to delete. So I'll create, I will have two pointers, temp and previous. So we'll traverse this node. Our temp very pointer will point to this and previous will point to this. So if we are able to do the to reach the last node and our previous pointer is storing the address of the one node prior to the last node, then we can, then what we can do, simply our previous, the next of previous will point to the head. In that case we simply need to write the next of previous is equal to head, and that's it. We don't need to set any other pointer, and we can safely free our temporary node like this. So this is the logic of our second method, delete last. I hope you understood. Now let's take the third case. Then we have to delete a random node with value v. I mean we have to, this involves the two steps. First we need to search the node with value v, and then we have to delete it. So suppose, okay, just a second. Okay, so in our third case, suppose this is our linked list. Suppose this is our circular linked list. Like this. This is our head node, 10, 20, 30, 40. Suppose user call the method delete node 30, right? So we need to search for the node 30. So we'll take two pointers basically, previous and current. We'll start initialize both of them with the head pointer. Current will be our current pointer and previous will point to the one node prior to the current pointer. So we'll traverse this linked list and we'll search for the element. Suppose our current is right now at this position. We found the element and our previous will be one node prior to this, prior to the current, and we have to delete this node. So what should we do? The next of this pointer will be pointing towards the next of current. So basically what we have to do, the next of previous is equal to next of current next. And when we have successfully made the connection, we can safely delete this current node like this, free current. So this is the logic that we are going to implement in our deletion functions, in all three deletion functions. Let's write the code one by one. So first, let me write the code for delete first function. So this is our delete first function. So void delete first. So first of all, we need to check if the list is empty, if head is equal to null, that means list is empty and we don't have any node to delete. So we can simply print the list is empty and we can return from there. Printf list is empty, and we can return from here. Otherwise, as discussed in the logic, we have to traverse to the last node. Sorry. So let's create a temporary node temp, and initialize it with the head node. Now we have to reach to the last node. If basically there can be one more case when we have only one node in the list. So in that case, the head will be pointing towards itself. So if next of head is equal to head, this means list contains only one node. So we can delete this node, free head, and now head is equal to null. Head will point towards null and we can return from here. Okay, now we have to do the traversal and need to reach to the last position so that we can safely delete the first node, that means the head node. While temp next is not equal to head, temp is equal to next of temp, right? So this condition, we will come out from this loop when this condition becomes false, and when this condition becomes false, next of temp will be equal to null, will be equal to head. I mean, we will be at the last node of the list. So like I just discussed, we'll create a struct, a temporary node that will store the address of the head node so that we can delete it safely. Not struct node, I'm calling this node as to delete and initialize it with the head. Now our simple 2-3 lines, head is equal to next of head and the next temp will join the temp last node with the new head, right? We have joined the last node with the new head, and our new head is the next of the current head. So now we can safely delete this node to delete, because it contains the address of our previous head, the old head, right? So to delete, and that's it. This is the implementation of our function delete first. Now let's write the code for the delete last. The second implementation is b void delete last. So first of all, we need to check for the underflow. I mean, if the list is empty, we cannot delete any node. So if head is equal to null, that means list is empty, and we can print list is empty, and we can return from here. After this, we need to check the case when the list contains only the one element. So if head is pointing towards itself, the next of head is pointing towards itself, this means the list contains only one element. So we can safely delete the only element of the list using this free head, and now the head will be pointing towards null. Head is equal to null, and we can return from here, right? Otherwise, as discussed in the logic, suppose this is our suppose linked list, circular linked list. We have to delete the last node, right? We have to delete the last node. So I'll create two pointers. Somehow we have to reach to the, if this is the head pointer, this is our first element, and we want to delete this one, this node. So I need to access the one node prior to the targeted node, I mean this last node. So I'll create two pointers, node temp is equal to head, and one more pointer previous, initially it is null. Okay, now while the next of temp is not equal to null, we have to traverse this loop, and what I will do, previous is equal to temp, and temp is equal to next of temp. So when this loop will be completed, will be at the value of temporary pointer, the temp will be pointing towards the last node, and then we can safely join this. We simply have to write the next of previous is equal to head, and we can delete the temp. This is all we have to do. So we can write here the next of previous is equal to head, and we can safely delete this temporary node, and that's it. This is the implementation of our delete last function. Now our last delete function, C, that is delete node, void delete node int value. So user will call this function like this, delete node, suppose 30. Suppose this is our circular linked list. Like this. This is our first node, that is the head node. Suppose it contains values like this 40, 50, etc. Now as per the request we have to delete this node, right? We have to delete this node. So if I need to delete this node, what we need to do, we have to somehow connect its previous node with its next node like this. So we need two pointers, one previous pointer and one temporary pointer or the current pointer, like we used in the last implementation, right? So first of all, let's first if we have these pointers, then what we need to do, I'll simply store the previous of next will be pointing towards the next of current, current next, and we can then delete the current. So this is the logic. Now let's handle the different cases. Like the first case is when the list is empty. So if head is equal to null, that means list is empty. So we can simply print list is empty, and then we can return. After this, we will initialize two pointers like we have done in the previous case. Current is equal to head and previous, initially previous is equal to null. So now handle the different cases. If suppose the value that we are searching for is the first node, delete. Suppose the data of head is equal to value, that means we have to delete the first node. So we can simply call our function delete first, and this will handle this, and after this we can return from here. Otherwise, let's apply the loop like this. Previous is equal to current, and while current is not equal to head, I mean if the current is equal to head, that means we have traversed the complete list, and current data is not equal to value that we are looking for. So we will come out from this loop. This loop will be terminated if any of this condition is true. I mean either the data of current is equal to value, I mean we have found the node that contains the value v, or we have traversed the complete list and could not find the value. So these are the two cases in which this loop will be terminated. So inside this we simply previous is equal to current, and current is equal to next of current, right? So if Just a second. So if current data is equal to v, that means we have found the node with data v. So in that case, what we have to do, we have to simply write this two lines. I mean previous next is equal to current next, and when you have set the pointer, you can safely delete the current node, right? Else means we have traversed the whole list and we could not uh, found any node with value v. So that means here we will simply print that node with value percentage d not found. Right. So this is our implementation of the delete value method. I hope it is clear to you. Right. So after implementing all the variations of insertion and deletion functions, so now let's implement the another function, count nodes. So this function will basically count the number of nodes in the circular linked list. Let's implement this. I mean in the count nodes, we simply have to traverse the linked list. We'll declare a variable count and initialize it with 0 and increase its value inside the loop. So first we need to handle the underflow condition. If head is equal to null, that means the list is empty and we can return 0. 0 means the list contains 0 nodes, right? After this, we will declare a variable count and initialize it with 0. Now let's declare a node temp and initialize it with the head. Now we have to traverse the whole linked list. The list we will traverse until we are at the head position, right? So we will use a loop like this, while the next of temp is equal to, sorry, while, let me take the eraser, while temp is not equal to head, and then just a second, we cannot use while loop here, because if I am writing like this, while temp is not equal to head, we have initialized temp with the head, so this will not enter into the loop, because temp is not equal to head condition will be always false. So we cannot use the while loop. I'm sorry, we cannot use while loop here. We need to use do while loop. Do while loop here. We need to use do while loop here. Do count plus plus temp is equal to next of temp, and here we can check the condition while temp is not equal to head, and after this we can return the count. So I think you understood why we cannot use while loop here, because if we use while loop like this, while temp is not equal to head, we have initialized actually the temp with the head. The value of temp is equal to head, and this condition will never be true, and we will not enter in the loop. So that's why we need to use do while loop in this case, because we have changed the value of temporary pointer inside the do while loop, and then we can check the condition. uh, I also need to correct one function in the implementation of our insert after method. We are checking the condition. Let me come to the insert after. Just a second. Okay, here also we have done the similar mistake. Since our temporary node is equal to head, and we are checking it using the we are using the while loop, so we'll never be able to enter in this loop. So this loop need to be changed. We should use do while loop here. Do while temp is not equal to head. Now the code is perfectly uh, now the code is okay. I'm sorry for the mistake. Okay, let's come to our next function. We have implemented count nodes. Now the next function that we have to implement is the search function. So search function, let's write int search and value. This function will return true or false. I mean 0 or 1. 0 means the value that we are looking for is not found in the list, and 1 means the value that we are looking for is found in the list. That's it. So first we need to take care of the edge cases, like if head is equal to null, this means the list is empty and we can return 0, means the value that we are looking for is not found. Then we have to traverse the list, and for traversing we need to define a node, a temporary node. We'll initialize it with the head, and here we will use a do while loop. If the data of temp is equal to value that we are looking for, we will simply return 1 means true, that means we found the value, otherwise temp is equal to next of temp, and this is the loop while temp is not equal to null. And finally, if even after the after completion of loop, if we could not find the value, then we'll return 0. So this is our search function, and likewise we can implement the display function, I mean our traversing function, void display. So this will be exactly same. We'll first check for underflow. If head is equal to null, this means we can print that the list is empty. Printf list is empty, and we can return from here. Otherwise, we'll declare a temporary node like this, and we'll use a do while loop to traverse the list. So first print the value, printf %t and temp data, and traverse the node like this. Temp is equal to next of temp. This is our loop while temp is not equal to null. So basically this will print all the nodes of the list, and after printing all the nodes we can print head because it is a circular list. So the last node is pointing towards head, so after this we can print head. This is the implementation of our display function. So I hope you have understood the implementation of all the functions that I just discussed, and now let's try to implement this in our online compiler. In order to save the time, I have already written the code here. This is the definition of our structure, the definition of our node. The node contains two data fields, one for storing the data and another for storing the address of the next node. We then declared a global pointer head. This is the implementation of our function insert at beginning, then insert at end, and insert after. Here, in the insert after, we have to use the do while loop, right? Because we have initialized the temporary variable with the head, and in the loop we are checking that this loop will run until temp uh, is not equal to head. So while loop will not work here. After this, the implementation of delete first, delete last, and delete node. After this, we implemented three functions: count nodes, which counts the number of nodes in the linked list, circular linked list; then a search function, which will simply tell you that whether a value is there in the list or not; and the display function to traverse the list. And this is our driver code. So basically what we are doing, we first inserted some values in the at the end of the list and displayed it. Then we inserted a value at the beginning, and again we are displaying the list. Then we insert after a certain value 20, we again display the list. Then we are counting the total number of nodes, delete first, delete last, etc. Let me run this code and check the output. So this is the code and this is the output. So you can check. We have inserted four values at the end. The first value is 10. After 10 we inserted 20. After 20 we inserted 30, then 40, and this is our head pointer. Then we inserted a value 5 at the beginning. So this is 5 at the beginning. After that we are inserting 25 after the 20. So we inserted 25 after 20, and then we are counting the number of nodes using the count node function. So there are total 6 nodes in our linked list, and then we are searching for node 25. So 25 is found in the linked list, and after that we call the delete first function, which will delete the first node of the linked list, circular linked list, that is 5. So after calling the first delete first function, our first node is deleted, you can see. And then we call the delete last function. Delete last function will delete the last node, that is 40. And after that we are deleting by value, and the node that contains the value 25 is deleted. And finally we are left with 3 nodes in our circular linked list. So this is the implementation of circular linked list. In this particular example, we have implemented the circular linked list using singly linked list. We can also use doubly linked list for implementation of circular list, right? So thank you very much for your patience, and I hope you enjoyed the video. In the next video I will implement the circular list using the doubly linked list. Thank you very much.